In this lecture, we are going to discuss about example on interior of a set in a metric space. So that one interior of A union interior of B is a subset of interior of A union B. Interior of A intersection interior of A intersection interior of B is equal to interior of A intersection B. Solution. First one, let x belongs to interior of A, x belongs to interior of A, interior of A union interior of B. If x belongs to interior of A union interior of B, that means x belongs to either of the interiors. This implies x belongs to interior A or x belongs to interior of B. That means there exists some real number r greater than 0 such that SR x open sphere center at x and radius r is containing A, or open sphere center at x radius r containing B. That means this open sphere SR of x is containing A union B. That means this x belongs to their interior of A union B. We have considered x is any arbitrary element in this intersection. We have found that after calculation x belongs to this intersection. That means this is a subset of this one. Therefore, interior of A interior of A union interior of B subset of interior of A union B. Okay. Next we are going to prove second one. This one. Let again consider let x be any element x belongs to this intersection A intersection B. Then x belongs to both the interior A and interior B has x belongs to intersection. So x belongs to interior A and x belongs to interior B. This implies x belongs to interior A. That means there exists some real number. There exists some real number R1 and x belongs to interior A R1 R2 greater than 0 such that as R1 x is containing A and as R2 x containing B. Okay. Now we are going to consider R equal to minimum of both R1 and R2. Minimum of R1 and R2. I am considering our R to be the minimum of R1 and R2. Then as Rx containing A and as Rx containing as R is the minimum of R1 and R2. So this happens. So this implies SRX belongs to A. SRX is containing A and this containing B. That means it contains contain in their intersection. Is if SRX contain in their intersection, this implies X belongs to interior of their intersection. Okay, we have taken X is an arbitrary element in this intersection. We have by after calculation we have found this X belongs to this intersection. That means this is a subset of this one. That is interior A intersection interior B is a subset of interior A intersection B. To get the equality here, we have to show the reverse inclusions. That is interior of A intersection AB is contained in interior of A intersection interior of B. So consider let y belongs to interior of A intersection B. When y belongs to interior of A intersection B, that means center at y, there exists some open square containing this set for some real number r greater than 0. This implies there exists some real number r greater than 0 such that as r y is contained in A intersection B. So this implies SRY is contained in A and SRY contained in B. Okay? If this happens, then Y belongs to interior of A and Y belongs to interior of B. Okay? Now Y belongs to interior of A, Y belongs to interior of B. So Y belongs to interior of A intersection interior of B. Interior of A intersection interior of B. Y is an arbitrary element of this intersection. After calculation, we have find that Y belongs to this intersection. That means this is a subset of this one. That is interior of A intersection B is a subset of interior of A intersection interior of B. Okay, here we have calculated this one, okay, and here we have find from these two we get the equality. Okay, from these two we get the equality. Hence, the equality. With that, I would like to conclude. Remaining will be in the next lecture. Thank you.